Okay, and don't worry, I wrote about this 8:30. It's not like a kind of red line, it's just in order to be more compressed. So I think the best thing is that whoever has a question will raise it. I can share the screen and show the project if needed. Is there a need to share the screen?
I don't think so, unless it comes up.
Okay.
Okay.
Okay. Irene, would you like to start?
Sure, thank you. Okay, I have a question for exercise 1, where we have the data set of EEG data, and I'm not sure if we're supposed to look at all of the channels of each participant, or one channel or a few channels per participant to determine statistical features.
Um, okay. I'm checking. I think, as far as I remember, you need to open all of the channels.
Okay.
This is as far as I remember. Yes. Yes, you need to open all of the channels. Yes.
Okay, thank you. And then for exercise 2, when it says that we need to do 2 seconds per method, does that mean that we need to do 2 seconds per professor and not 2 seconds per wave, right? So can we do, for example, for one professor, 2 seconds, one being the awake state and one being the asleep state, or does it have to be 2 and 2?
We are meaning to do it 2 and then 2. So
Okay,
you have this sine scatter plot, and then it just turns into a much more dense one.
okay, but each wave should be 2 seconds, or the whole experiment type should be 2
No,
seconds?
each wave. It's like a very simplistic idea that you need to transition between one wave into another.
Okay, and if the plot looks too compressed, that's fine, because for 2 seconds overall, it looks way better.
Yeah, I would probably zoom in
Okay,
to a part of the plot. I mean, like first show the full plot and then zoom in into
okay,
one of them.
okay.
And
Um,
even when they are compressed, it's really okay. You can still see.
okay, thank you. And when you say assume amplitude of 1, do you mean the peak amplitude or the RMS?
What do you mean by the RMS?
So as far as I understand, there's a difference when you set up you do signal equals a scalar value times numpy sine of whatever, and that's your peak amplitude, and I can set that to 1. But then
Yeah.
the RMS is gonna not be 1 if I do that. It's gonna be 1 over square root of 2.
Right. Aha.
I couldn't hear you.
There was a problem with my internet connection. So you said 1 over.
So the RMS of a peak amplitude of 1 would be 1 over square root of 2, right?
No, it's the peak amplitude. It's much simple. If your function is a sine omega t, then it's the a. It's just the peak amplitude. It's very, very simple.
But then when I calculate the RMS, that's gonna be like 0.7, right?
I don't fully understand what do you mean by the RMS.
The root mean squared. So like the way that you would actually calculate amplitude by taking the squares of all of the samples in the signal,
Yes.
then doing divided by the length of the signal and then squaring it. That's not gonna coincide with one.
No, no, no.
Okay.
This is too complicated. No, keep it simple. It's only the
Okay, only the
magnitude of the perturbation or the magnitude of the sine function. Okay?
thank you. And then why did we correct the log formula for the SNR to not being 10 log 10 of ratio, but just more so than why should we apply this for all of the subsequent calculations all throughout the plots,
Yes,
for
yes.
example? So not
Yes.
multiplying it by 10, never.
Yeah, don't multiply it by 10. Yes. The
Okay.
thing is that if you multiply, you can write. But the thing is that when we built the project, we were so used to the fact that commonly they don't multiply by 10, so that I forgot about multiplying when we were writing the project, and only when we were in class I got remembered. So this is the reason we did a little mistake.
Okay.
When should we do that? Is it in the second exercise?
Yes.
Okay, so not multiplying by 10, it's the SNR?
Yeah, no need to multiply by 10.
Okay.
I don't remember, by the way, an SNR question in the second one. What section is it?
It's I think E or F.
Okay, yeah. Okay.
Okay.
Yeah,
That's
so
what
don't
happened.
use the 10 over the log 10 of the ratio. Just log
Okay.
of the ratio.
Thank you so much. That's it. Thank you.
That's it? Wow, that was simple. Very small technical questions, Irene.
For now.
Okay. This is a good sign. Yeah. More questions?
I just want to ask something regarding what Irene has just asked. When you said that we should look at all the channels for the first exercise, what do you mean with all the channels? Because I see the 200 subjects. And for me, those were my like subsample for the ergodicity break. So I don't understand the channel concept.
So I think that Irene, let me open for a minute the CSV. So the CSV is okay. I think that okay. I'll just show you the screen. So what we see here is that we have this 200 participants, and for each one, Irene, what did you mean by sources? It's not 3 dimensions, it's only 1 dimension for each one. Did you mean these numbers?
Yeah, I think this whole time I got confused actually.
Okay. So
It makes more sense.
in this matrix, what we see is that each line represents a subject and each column represents a time. Okay, so I was also a bit confused by your question.
Mhm.
So in a way, you might say that for each of the recordings, each recording is a source, and then you're asked about if either one of the sources is ergodic or so. But I don't want to go into sources, because what you need to see is only the simple matrix of subjects and the recording itself. Okay.
Okay.
And
Thank
you
you.
have 3 files of each. So I hope it is more clear now. Araceli, do you have more questions?
I just wanted to ask about the third one. It says use millisecond beans to create the spike train. So I was wondering if this millisecond beans is 1 millisecond.
Where is it? In
Number 3 in the very first paragraph.
yes, it's 1 millisecond.
Okay. Thank you.
Noah?
Yeah, I have a question about the fifth formula in the article. I
Mhm.
thought I understand that, and then in D part you said to put it in the code, and then I understood that I probably didn't understood because I have no idea how to do it in a code and what I need to do, like what is the lambda and what is the xt, what I put in there, what is the values.
So I'll share the screen. We were talking a bit today about this formula. Are you talking about the ergodicity break?
No, the in box 4.
In box 4. Right.
I think it's ergodicity break.
Yes. So the basic idea is it says that right this statistic phrases deviation of squared subsample variance from squared variance total sample variance as a proportion of a squared total sample variance. So what you should do here is that you need to take each possible subsample, right, of your subjects. And then you calculate the variance of all the subjects together, and you subtract the variance of each subset.
Like it's
each-
subject.
No, not subject, each subset.
So I don't understand what is the subset
So,
in our data.
okay. So first of all, one of the things that you need to change is that you don't want to calculate it over T. You want to calculate it over the across the subject. Therefore, in here they use these time samples, right? And instead, your x-axis will be the subgroup size. It will be more like this one, okay? But your y-axis should still be the ergodicity break. Okay? And
Okay.
then for each subgroup size, you need to calculate the ergodicity break by averaging across all possible subgroups. For example, if you have 200 subjects and then you pick 8, so you will pick randomly 8 and then pick again another subgroup of 8 and another subgroup, and then you will have an average, right?
Okay.
And then in this average, you will bring the ergodicity break.
But I choose randomly the subgroups.
Yes, and for each subgroup, you need to simulate it again and again across all possible subgroups.
I don't think I understand.
Okay, so the idea behind ergodicity breaks, okay, let's look at the formula and then maybe we can understand it better. So why do we call it ergodicity break? Because ergodicity is that when you have a subsample, it should have the same variance as the total sample, right? This is basically the idea. And you want to find what is the point in which the subsample becomes different than the total, right?
Okay.
So let's say, for example, that for every random 10 people that you take, 10 subjects that you take from our data, their ergodicity, their variance is the same as the total, okay? So what you need to do is now take all the possible groups of 10 people in your data. So if you have 200 subjects, you can randomly pick 200 over 10 groups, right?
Okay.
So, and for each one, you calculate its variance, and then you average across all the variances, okay?
Okay. But
And then you subtract the
it
total variance from this subgroup variance.
Okay.
And this is this subgroup ergodicity break, okay?
The average that you calculate is just the average of the subset of subjects, right? It's not of
Yes.
the 200. Okay.
Yes. So, for example, this average is for all possible groups of 10 out of the 200 subjects.
But then if we want to get a graph like the one shown in the paper, with more and more samples, with more and more time, the ensemble variance has to be fixed in certain interval. And then if we want to change the subset of the ensemble variance, then the number of subjects has to be fixed, no? And then we would have two graphs showing different amount of subjects and the other one different time intervals, right?
The time interval is for stationarity. In ergodicity, you need only to look across the different subjects. So when you want to measure the ergodicity break, you need to measure it across the distribution of subjects and not across the time. So what you offer is another idea that you can check, but you are not obligated to, regarding the stationarity.
Okay.
Okay.
Yes.
Noah, do you want me to re-explain it in Hebrew? Will it be easier?
I just didn't understand because in the graph, like here, the subgroup size is getting bigger and bigger.
Yes.
But if I'm using the same like 10 size of subgroups, I took 10, 10, 10, 10.
Right, and this is only one dot here.
Yes, but still, the subgroup size still will be 10.
Right, and this is the dot for subgroup size of 10, only this dot. And then you take 20 and it will be this dot. You take
Every
each
time
dot.
I need to make the
Yes.
subgroup bigger.
Yes, and each subgroup you take randomly, you repeat it again and again for all the possible subgroups within your
Okay.
subgroups, okay?
I'm just don't understand how to actually do it, but I will try tomorrow.
Okay, so what you should do, you first of all need to randomly take, you need kind of make a list of all possible, okay, I will tell you how would I think about it. I would first try to kind of create a list of all possible subjects in group. For example, the subgroup or one. Okay, first subgroup of 10 people will be subjects 1, 3, 8, 7, blah blah blah. And then I shuffle and randomly pick again until I have all possible shuffles, all possible combinations,
Okay.
right? And then for each one of them, I would calculate the variance.
Okay.
Okay.
Okay. Yeah. And
So
I
then,
have another.
sorry.
Yeah, sorry.
And please note the variance, how you calculate the variance, you need to explain yourself, right? Because for each subject, you have all the possible numbers. across the trials, right? All the recording. So you can say, for example, I take all of the recording and I average it into only one, and then for each subject I average it, and then I look at this distribution and I calculate the variance. Okay, or you
Okay.
can say I take only the first 100 milliseconds or something like that.
Okay.
It's kind of games that you can play.
Okay.
There is no right or wrong here. It's the kind of things that you need to justify yourself by your claims. And unlike most of the courses that you've done, in this type of projects, you really need to be creative, and there is no right or wrong. The only question is, how good did you justify your choices?
Okay.
Okay.
The other question I had is about the word limit. I didn't understand it say 500 for what, because I think I way over it.
It's okay. It's okay. 500. It's kind of a way to tell you don't try too much. But I know that in question 1A, 500 is impossible.
It took me like a
told me.
full and a bit page just for the first dot.
Okay, so leave it like this, and I'll change it only for section 1A. But
Okay.
for each one of the dots, okay, let's say that for each one of the subsection question, it shouldn't be more than 500 words. Is that possible?
I will walk through it.
Okay, great.
And another technical, you said that you will send me, and I forgot to remind you, but you said you will send us an example of a answer for what Izar will
Oh.
want.
Right. So yeah, so tell me and I'll send you an example of something that I did.
Okay.
I'm sorry
Perfect.
I don't
That's
have
it.
it in English. I'm sorry in advance. I will look for something in English. And maybe I'll upload it also, so that you can see how a good answer looks like.
Okay.
Okay.
Thank you.
Are there any more questions?
יש בעברית, אבל אני אחכה שהם יסיימו ואז אני אשאל אותך.
Okay, so Tal just said that she would like to ask a question in Hebrew, but she wants us to first finish with the English questions and then she will ask. But I think, Tal, that you can ask in Hebrew and I'll just translate. I'll answer and then answer in Hebrew and then translate.
לא, אבל זה לא כאילו קשור לכולם, זה משהו ממש ספציפי, אז הכל טוב.
Okay.
זה לא משהו שרלוונטי להם.
Okay, so she says that it's something that it's more relevant to, that it's a very small thing, and she will just ask me later. Okay, no problem. So I just wanted to tell you that we thought about the deadline for a submission, and there is a high chance I'll see what will be your a status at Sunday, and there is a high chance that we will give 2 more days until the 24th of May, which is a Friday. Okay. And if someone sees that he cannot submit all of the questions, and by all the questions, I mean that if you have, for example, I don't know, even a partial answer to some of the questions or something like that, it's still okay, but you need to submit all of your questions. And if you see that you won't make it, so you can also submit 2 weeks, even 2 weeks later, but then you will be reduced by 10 points. But the main idea is that we don't want you to submit only half of the project, okay? Because this is a very important project for you to get ready for the quizzes.
Okay, thank you.
You're
Bye.
welcome. ביי נועה, תרגישי טוב. Feel
תודה.
good.
Thank you so much. Have a good night.
You too. That's it, Aylan? You don't have a question?
No, I was just listening because
Okay.
I'm at profit because I'm doing the quiz right now, but yeah, I haven't started with the coding part yet. So yeah, it's
Okay.
happened. Yeah, thank you so much.
You're welcome.
Thank you so much.
You're
Bye bye.
welcome. Bye.